All right, so we made both of these parts that are represented here on this sheet. And next we need to make the rod that connects them together. That'll be this guy right here. And this guy is going to have a three-sided flat, 120 degrees separated, for the LED arrays that are going to be mounted there. And screw threads to pull the part together, to pull the whole light together. That's what's going to put the force to create the water tightness, I'm hoping. So that's the part we're going to make next. This is at its peak 2 inches diameter. That's its side profile. This is 2 1/4 inch material, so I got to take this down. I'm going to face it, put a center drill hole in the end here so I can use a live center, and then stretch this guy out, and we're going to make this part. Facing off the end that I center drilled a little bit deeper and increased the feed rate, so I'm actually breaking chips, which is nice. It's 9 thousandths a revolution at 440 RPM. Next up, we're going to start by getting the X diameter right. It's about 2 1/4 inches, and we need to take it down to 2 inches. So got a little bit of material to remove. So we'll do a 50 thousandths pass at 9 thousandths a revolution. So the part is going to be, final size is going to be 6 inches. So we'll just go a little bit past that. So next up, I'm just going to use my parting tool, and I'm going to go in almost all of the way, so I have a good stopping point. That's where this bottle with the long stainless steel needle is really handy when you're parting. You can get in there and put the lube right where you need it. Now we just need to take this whole section down to that diameter. But as long as I got the parting tool in, I might as well mark the other side as well. Now here's a big gotcha. So remember, I was referencing off this side of the cutter, except I want this edge here to be 4 1/2 inches from this edge. So I need to take into account the 127 thousandths thickness of that guy. And just for a sanity check, let's see if we hit 4 1/2 here. And looks like we're right on the money. So perfect. We're going to go in 1 inch again. And we're good. The center section here, I'm keeping about this much of it as round and then milling some flats, but then I've got to put some dishes in it with the radiusing tool. So I'm leaving room to do the radiusing tool. Now we're going to do 100 thousandths depth of cut passes, 9 thousandths a revolution feed until we get down to that final diameter, and we can just stop in this groove here. So that shouldn't be so bad. Now when I go, I'm going to leave this 1 inch section on here, but when I come back, my, actually it's supposed to be 0.998. I'm going to leave a 1/2 inch at 1 inch and then relieve in 1/10 of an inch the remainder, but I'll do that after I'm at the very end. I'm going to put a chamfer on the front for the threaded section. So I'm just using the Kennametal parting tool here to remove the bulk of the material down here. It's a very versatile tool. Okay, now I got to remove these floaters out of here. like this little disc I left. And these two guys. Then I will show you how well this tool works side cutting. So we're going to head down to 0, and then we're going to traverse. I think if I'd been really smart, I would have done the radius over here and the radius here before I thinned this section out here. That would make it stiffer, but I didn't, so we're going to live with it. And remember, I'm also going to relieve this section and this section in 1/10 of an inch with 1/2 inch of threads on each end. And to put the threads on, I've decided not to single point it. I'm going to use a die just to try it out, because I haven't done that much with big threads, to see if I even can do it reasonably. Okay, there we go. And if I touch this, it actually won't be a problem, because it needs to go in another 1/10 of an inch. Which means I'll have to come back with the radius tool at some point. That's on one side. Now I just need to move over and do the other side. Oh, that looks pretty good. Now we're going to do the other side. Same thing. Okay. That was pretty good. Not much chatter at all. I was blown away at that. So I don't know if you can see this, if it'll focus, but the left side, you see the built-up edge. That's no lube. Right side, I use lube. A lot less build-up aluminum welding on the insert. This is not an aluminum insert, aluminum cutting insert. The coating isn't anyways. I'm gonna chamfer the sides here. Okay, those are matching. Oh, I didn't blend that very well. But again, it's not going to be a problem, because remember, this gets relieved another 1/10 of an inch and I'll blend it then, final blending. So now I just need to part this guy off. And I need to add some lube so we don't get any welding. And that's it. There's the partially finished part, ready to move on to the next step. Alrighty, so the next step is to mill 3 flats on this guy, each 120 degrees apart, so they'll be symmetrical. It doesn't have to be anything close to exact, because it's mostly for aesthetics. So rather than put this in a rotary head, I don't have an indexing head. I do have a rotary table that I could put horizontally, but I don't have a center, and so it would need to stick out. I do have a 3-jaw chuck for it, or a 4-jaw chuck for it rather, but that seems like the hard way. So what we're going to try and do is pop it in this hex holder here with a 5C collet. That's why I left these 1 inch on purpose. And we're going to tighten this guy up, and then we're going to machine these flats. So I've got the part mounted in the vise, but there's a fair amount of stick out here, and I probably could get away with it. But just to be safe, I've got a machinist jack, and it comes with a whole kit of extensions, and one of the parts is to have this sit on top of something round, but I can also use this upside down to support something round. So we will do that, and we'll just put it on here so that it's snug. I don't want to actually jack this guy up and make it other than flat. All right, so that'll support the end, and we can just mill this 3 ways to Sunday, as it were, and put 3 flats in it. And I want to go down. What I did was I drew the circle around it drew the inset parts that I needed, the length that I needed, which was a little bit wider than the whatchamacallit, the LED array itself. And as long as I'm at it, I also have to drill some holes. What I'm going to do is I'm going to do the flats first, and then we'll come back and drill the holes, the mounting holes for the LED arrays. And in case you want to see what an LED array looks like that is going to go here, I'll bring one over and show it to you. So here are the LED arrays. I actually have some extras. And it's made up of quite a few LEDs. These are 12 volts a piece, nominal 12.4 at 2.4 amps. Quite a few lumens, something like a couple thousand lumens a piece. We're going to push them at about 1.2 amps, about half max, so they get better life out of them. You don't gain a lot by pumping them extra hard. I've got my 0 set. We're supposed to go down a total of 0.325. See, first pass, we'll do 100 because it's not going to bite very much material. But it is going to make a hell of a mess. I don't know if you can see easily from the drawing here, but all of the relationship of the alignment of the LED array is based on the center lines of the part. Center line down the middle, halfway between these two spots, and vertically dead center on the axis of the part. So all I need to do is take my indicator and find my 0 here, and it's 3 inches in as the center, and then find the center of this guy, and that will align it along the axis, and I will have my X and Y position for the center. All right, next up, we're going to drill and tap for these two mounting holes. They're 440 mounting holes, and so we're going to center drill, and I just did a sanity check by putting these here. Alrighty, so put some 3M tape on here, painter's tape, just to protect it from major scratching. It's not really a huge deal, it's purely aesthetic, and there's not a lot of precision needed in this particular operation. The relief is important, but not essential. Not a precision operation again. I just want at least a 1/2 inch of threads, which is there. We'll do a little bit more than a half. I think we'll stop about here. There we go. That's a nice looking finish, isn't it? All right. Now we just need to put some threads on here, and that should be challenging because I'm going to use a manual die, at least try. I'm trying to avoid single pointing these, just to get the practice and see what I can and can't do. Alrighty, so we may have to use my chuck key to turn the chuck here, but the goal is going to be to try and manually tap these threads. Wow, tough. Okay. There's a test of the threads just to make sure they're okay. So that's good. So we are all good. So interestingly enough, these are split dies. So when you tighten these outer two screws, it makes the threads go deeper. If you tighten this one, it opens the threads up a little bit. And the threads were too tight for the matching tap. So I have tightened these two, and I'm doing another pass, and it is removing material. I was trying to do it with files, but that wasn't cutting it. So hopefully this will get us right on where we need to be. So here's the part, and the top part, the threads are a little tight. The bottom part, when I took the die over the second time, for whatever reason, it tore the threads off the back. So I'm gonna have to remake this part, but there's enough threads that hold really tightly on the top for me to test this out. So I'll be able to put it together and test it with this part, and then make another one when I finally give it to my brother-in-law. And the tape was inadequate. It looks like I still have some marks on the face there, so that's not a perfect idea either.